Hello and welcome to our first physics homework video for the homework about angled projectiles 2 due on October 9th, 2023. The first problem I have is about the long jumper. So here we can see that the long jumper will leave the ground at an angle of 17.7 degrees. And this vector will have a speed of 10.2 meters per second. We want to find out the distance that this long jumper will jump. So we can draw a parabola showing his motion, and this is going to be the x distance that we are trying to find. So the first thing that you'll want to do is find the x and y components of this vector, like this. So this will be velocity y and velocity of x, which can be done using trig. So 10.2 sine of 17.7 will get us 3.1, which is going to be the y component, and the x component can be found by using cosine. So 10.2 cosine of 17.7 is going to be equal to 9.7. So next you will want to use the distance formula, which says that d distance is equal to the initial velocity times time plus acceleration times time squared over 2. In this case, we are trying to solve for t because that variable is unknown and it'll later be used to calculate the total distance traveled in the x direction. So to do this, we will plug in the other values by solving for, by using the y component. So we know that the jumper ends up over here at a 0 y position and starts at a 0 y position, meaning that the change in distance is 0, and then here the initial velocity is going to be this 3.1 we found earlier, so 3.1 t plus negative 9.8 for gravity, a t squared over 2, and then we can solve for t, so subtract 3.1 t. So I can multiply this by 2, so negative 6.2 t. Then divide by t. And then we can divide both sides by negative 9.8. And doing the division, this is going to be equal to 0.63. Now that we have found the component for time, you can simply multiply 0.63, which is t, by the x component, which is 9.7, which gets you 6.111, which rounded, I put into UTexas as 6.1 to get my answer for the first problem. So next, for part 2, what you'll want to do is take t and divide it by 2. What this gets us is the point in the middle of the parabola, because parabolas are symmetrical. That means that this will be the maximum point that the jumper will reach. So t over 2 is also equal to 0.63 over 2, which is 0.315. So next, what you'll want to do is to find the y component, you'll want to plug this into the distance formula, which is again VIT plus a times t squared over 2. So this time we're solving for the distance in the y direction. So you have d equals vi, which is so 3.1 times 0.315 plus acceleration due to gravity, which is negative 9.8 times 0.315 squared over 2. Now you can just plug this into a calculator, and you'll get back that d equals approximately 0.49. Note that on this particular problem, UTexas may reject overly rounded answers, but 0.49 worked fine for me for this specific set of numbers. The next question for me is about the golf ball. Here's just a little chart. So here we're going to have the golf ball launched at, this is going to be 87.9 meters per second. And then here we have another parabola. So we are trying to find this angle between this vector and the ground. So the information that we know is that here the ball travels a total of 197 meters, and this initial speed. So what you'll want to do is you'll want to use a formula known as the range formula, which we will have a video on how to derive it in the video description. I highly recommend you watch it to understand the physics better. So the range formula is going to be d, distance, is equal to v squared sine of 2 theta over g. Yes. So we are trying to solve for theta. So to do this, we'll say that d, g, so multiplied by g is equal to v squared sine of 2 theta. And then we divide by v squared, so dg over v squared equals sine of 2 theta. Okay, so next you want to put everything in an arc sine. So arc of a trig function is the same thing as its inverse of dg over v squared is going to be equal to 2 theta, which means that dividing everything by 2, so this is going to be the way we solve for theta. So since this first question asks for the minimum distance, what you'll want to do is just take the basic value of theta that you'll get from a calculator and use it for your answer. So to plug in my numbers for this equation, I'm going to want to do arc sine of 197 times 9.8 over 87.9 squared. over 2. The reason that we use 9.8 as opposed to negative 9.8 is because it asks for gravity, so the formula is going to factor in the negation of gravity if it are used for acceleration. Putting this into my calculator, I'm going to get 7.23 as my result, which is correct. So next, I'm going to skip over part 2 and all the way to part 3. So what part 3 deals with is the ambiguous law of sine, which means that if you remember from trig, a sine graph looks something like this. So this will mean, because arcsine is taking the inverse of the function, we're trying to solve for x from y. If you say that y is, let's say, here, and we're trying to solve for x, the result could be an x value here or here. And this is what we're trying to account for in problem 5. It asks for the larger angle. So what we'll do is I'm going to backtrack a little bit from this previous problem. So if we take this equation from here and then use the ambiguous law of sine, you can find that. So the arcsine, we're going to do the arcsine. Going to do the arcsine of 197 times 9.8 over 87.9 squared. So that is going to have a value of 14.46 for me. So now to find the other value that this angle could be, it would be 180 minus 14.46, which is 165.54. Now, of course, we're not throwing launching the golf ball at an angle above 90. But so if you remember from here, we're going to divide this number by 2. 195.54 over 2 is equal to 82.77. So that's your answer for part 3 of that problem. Whoops, no dot here. But continuing on to part 2 of the problem, or question 4 for me, it is going to ask for the maximum height in units of degrees. Now this is a typo on part of the people who made this problem. It's really asking for units in meters, not degrees. So you can safely use meters for this part of the problem. What we're going to do here is similar to the first problem. So you have this chart here, so we can find, so now that we know that this angle, so remember, since this pertains to part 1, we are going to be using the smaller angle, so this is going to be 7.23. This follows part 1, right? So so we can find the y component here, let's say velocity of y, by doing 87.9 multiplied by sine of 7.23. So this is going to be equal to 11.06. Next, what you'll want to do, asking for the maximum height reached by the ball, so we have to solve for time again, just like that first problem. And here what we'll do is, because again, the total displacement from on the y-axis is 0, we're going to use the distance formula is equal to velocity initial time times acceleration times squared over 2. Sorry, this plus, not times. And then here you'll want to plug in 0 for distance is equal to 11.06, because that's the initial y velocity we just calculated here, times time plus acceleration times squared over 2. So here what you're going to want to do is say negative 11.06, so subtract 11.06, t is equal to at squared over 2, so multiply everything by 2, so negative 22.12, t is equal to at squared, divide everything by t, so negative 22.12 is equal to at, and to plug in acceleration for gravity, negative 22.12 equals negative 9.8 t, so t is going to be equal to 22.12 over 9.8. I get a value for t of 2.257. It's rounded. And then what you want to do is you're going to want to divide that by 2 to find the middle point of this parabola, which is going to be its maximum value. So that's going to be 2.257 over 2, which is 1.128. So now that we have our value for time, which is so time over 2 was 1.128. 1.128. So you'll plug this into the distance formula, initial velocity times time plus acceleration times squared over 2. So the initial velocity is still 11.06 multiplied by 1.128 plus 1.128 squared times negative 9.8 over 2. Swapped acceleration and time here, but you should understand the point, and you'll get a result of 6.24. which is my answer for part 2 of the golf question. Okay, question 6. Student stands at the edge of a cliff. So part 1, so this is the curve of the projectile approximately, and it's asking for the time it'll take to fall. So here is, this is 31.1 meters. So remember that x and y components work separately, so you're just going to solve for the y component here, which will be done by saying that, so negative 30, using the distance formula, which is d equals initial velocity times time plus acceleration times time squared over 2. So the initial velocity is 0, so in this case d equals, the distance that the projectile travels is negative 31.1, so that is going to be equal to negative 9.8. So since the initial velocity is 0, we can just drop that term. So we're solving for t squared, so t squared over 2. So now we multiply both sides by 2. Negative 62.2 is equal to minus 9.8 t squared. Divide by negative 9.8. Negative 62.2 over negative 9.8 is equal to t squared, which means that t is equal to the square root of negative 62.2 over negative 9.8. remember, in this case, since time is always positive, you do not have to worry about any negative value coming from the square root. Okay. And here it'll say that time is going to be a value of 2.5, 2.519, which I'll just round to 2.52 for my answer into UTexas for part 1. So next is part 2 of this question. This is question 6. Now we have question 7. Question 7. So question 7 asks for this this vector. So this is it's asking for the speed. So because speed is scalar, it's going to be positive. So we don't have to worry about like negative acceleration too much. It's asking for this vector, which is basically the speed it's going at this point, basically an instant before it hits the ground. So here we can use the VF equals VI plus AT formula in order to solve for the y component, because the x component is already known from the problem. So for me it's 23 meters per second. So to solve for this, we're going to take the initial velocity, which is 0, VF equals 0 plus negative 9.8 times time, which we found out is 2.519. So the final velocity in the y direction is going to be negative 24.7 rounded. So now that we know both kind of to extend this a bit longer, just to visualize it better, have here, so this is still 23 meters per second, and then over here, this is the 24.7 that we just calculated, this y component, negative. So now we can just use the Pythagorean theorem, or in this case, the distance formula version of a different distance formula. So that's 24.7 squared plus 23 squared, remember for these two parts, all in the square root, which is equal to 33.8. And that's the answer for in meters per second for part 2. So now it's question 8. So it's asking for the angle below the horizontal that this projectile is going to land. So it's asking for this angle. So for this problem, all we have to do is take the arc tangent of 24.7 over 23, which is equal to approximately 47 degrees. So for question 9, we're going to be solving for the initial speed of the ball that is thrown. So parabola, it's going to land here. So this is a 44.3 meter pass. And the angle in this case is going to be 31 degrees. Okay, so going to want to use the formula. So we're going to want to use the we're going to want to use the range formula, and we're going to have a video in the description on how to derive it, which I recommend you watch. So again, so the range formula is D equals V squared sine of 2 theta over g. So in this particular case, we're solving for v. So what we're going to do is say that dg is equal to v squared sine 2 theta, and then divide everything by sine of 2 theta, so dg over sine 2 theta equal to v squared, and then v is going to equal dg over sine of 2 theta, like that. So this, yeah. So filling these numbers in, so v is equal to the distance, so 44.3 times gravity, 9.8. Gravity is positive because it's asking for gravity, not acceleration, so the negating it would be factored into the formula already. Yeah, on the square root, of course. And this is going to be the sine of 2 times 31. Now if I put this onto a calculator, 44. So this will give me a value of approximately 22.2, which is the correct answer for question 9 for me. Finally, it's question 10. So this is about the cliff divers at Acapulco. So there are multiple ways to solve this problem. The probably better one is to use a formula, a different version of the range formula. So in this case, I'm just going to use the distance formula to solve this. So distance formula is d equals initial velocity times time plus acceleration times squared over 2. Okay. I'll draw this one as well. So this is like where they're jumping from, down here. So what the problem is asking for is this straight line, this x component, because the y component for the y component for this initial velocity is 0. So so vy equals 0. It wants basically to get past this rock, because it doesn't really give us much information of the rock. We can assume that it's really asking for the lowest angle that you need in order to get basically exactly to the rock. So this rock is 9.28 meters away, and the cliff is 30.8 meters high. And then, yeah, it's the information that we're given. So what I'm going to do is solve for the time that it takes in order to fall this amount, because the y component is 0. Here we have negative 30.8 is equal to 0 plus negative 9.8 times t squared over 2. So multiply both sides by 2. 61.6, negative 61.6 is equal to negative 9.8 t squared. So then negative 61.6 over negative 9.8 is equal to t squared, which means that t is equal to the square root of negative 61.6 over negative 9.8. And this is equal to 2.507. So this question is asking, so this is 2.507 is the time it takes to fall 30.8 meters. So it's asking what what's the x component of this initial vector so that we make it 9.28 meters by the time the 2.507 seconds pass. So it is asking for, so the velocity is equal to the distance over time. So the distance has to travel is 9.28 over 2.507, which is equal to 3.7, which is going to be the x component of the velocity, which is the answer here. So that was a guide of sorts on how to do the physics homework due on Monday, October 9th, about angled projectiles. Let us know in some way if what we can improve, and thank you for watching this instead of asking in the Discord 5 times.